Hello, Year 5. Today is Wednesday, the 27th of January, and this is our science lesson for this week. Our learning objective is to investigate air resistance. What is air resistance? On the left there, you can click on the link to show you an explanation of what air resistance is. Also, if you can't click on the link from the PowerPoint, I will save the link at the bottom of the video on our YouTube channel. On the right here, a brief explanation of air and water resistance. Friction occurs when objects move through water or air. You investigated some friction a couple of weeks ago with the lesson from Mr. Forster, where you were looking at how resistance can affect the distance an object can travel. Air resistance is another type of friction between air and another material. For example, when an aeroplane flies through the air particles hit the aeroplane, making it more difficult for it to move through the air. It's the same for an object moving through water. If you go swimming, there is friction between your skin and the water particles. This is known as water resistance. Today we're going to investigate air resistance using a parachute. So we've got 3 questions to think about here before we get started. What makes a good parachute? Which parachute design features maximize air resistance so that it takes longer for the parachute to float down to the ground? How does the shape and size of a parachute affect the air resistance? So that's a really good question. That's going to help us with the basis of an inquiry question for our investigation today. Here we've got some examples of possible variables to investigate, so things that we can change to see if it affects the rate of how the parachute descends through the air. Okay, if you look closely at that word there, descent, we had an antonym to that word, an opposite to that word as one of our homophones this week. To ascent, to go up. Descent is to go down. So let's look at some of the variables we have here. First one is the material of the parachute. So underneath you can see there is a question, an inquiry question to the start of your investigation. So does the material of the parachute increase or decrease the speed of descent? Okay, so that's what we're going to look at today. There is another inquiry question below, but we're not going to look at that one. We're all about measuring how long it takes the parachute to land on the floor. Next one, you could change the size of the parachute to see whether that has an effect on the descent, whether it's faster or slower. And lastly, we could look at the length of the strings on the parachute to see what effect that has on the speed of the descent. Measuring and recording your results. There are 3 things that you'll need to measure. 2 you'll need to stay constant, and the 3rd will be the variable. So the variable is something that you change. So we've got the constant variables, they stay the same, and your variables that change. Can you think what they are? So the weight in newtons is the weight of the Lego man. That will be the person attached to your parachute, the height in which you drop your parachute, and the speed of the descent. So that's what we're measuring. That's the speed. That's our key measurement today to see what effect changing the different materials, size, and length of the string has. Okay, so I have decided to test the material of the parachute. So my inquiry question is, does the material of the parachute increase or decrease the speed of the descent? We're not looking at this air resistance one here. Okay, so for example, I might start with some paper to make my, I'm just going to put a P there because it's difficult to write with the pen. I'm going to use paper. I might use some tissue. And I might use so that might be a napkin, the tissue. I might use some old material, maybe an old t-shirt or something, which I can cut up. So I've decided on the 3 different materials, and I want to test whether they change the speed of the descent. So remember, when we're in science, we need to keep the constant variable so that the test is as fair as possible. So the things that I am going to keep the same for each test are down here. So I'm going to keep the size of the material the same. And here I've said 8 centimeters squared. So remember, centimeters squared meaning that all sides of my parachute, whatever the material, would be 8 centimeters. If you feel like that's a bit too small, you could increase that size as long as you keep it the same size for each material. The height of the release, so where I release the parachute from, the weight of the Lego figure, and the length of the string that is used to attach the Lego figure to each corner of my parachute here, each 4 corners there. Okay, so those are the constant variables that we keep the same, and the materials here are what I change. Now you'll notice in the results table here where we record what happens, we've got each material, I'm going to test it 3 times and then make an average time in seconds. So for example, if on the first test it took 12 seconds to fall to the ground, this one took 14, this one took 10. To find the average score, I would need to add up all 3 scores and divide it by 3 to find that average. So I would have 12, add 14, 26, add the 10 is 36. Sorry, it's quite difficult to write with this pen, boys and girls. I do apologise for the squiggly, not very neat writing. Okay, so adding that all together, you've got 36 seconds. Divide it by the 3 tests completed will give you the average score. So the average for test 1, 2, and 3 with the paper would be 12 seconds. Okay, so that is one possible test you could do, changing that variable, one variable, the material. Okay, let's have a look at some other variable that you could change. This slide here is showing that you could change the size of the parachute. So every single time I'm going to use exactly the same material, the height that I release, the weight of the Lego, and the length of the string. So this time my inquiry question would be, does the size of the parachute increase or decrease the speed of the descent? Okay, so I'm going to have a look, and I'm not doing that setting question there. I'm looking and only measuring the speed of the descent. So everything's the same material. I'm just going to change the size. So I might start off at 10 centimeters squared. Centimeters squared. Oh dear me, this writing's terrible. I do apologise. Then I might go up to 20 centimeters squared, and then 30 centimeters squared. And then again, just like with the other test, you would do the test 3 times to get your average score there. And then you can start to look back at your question. Does the size of the parachute either increase or decrease the speed from your results there? Last variable that you could change. So for this experiment, boys and girls, you don't need to do all 3. You just need to change one. So are you going to change the material? Are you going to change the size? Or this last one here is the length of the string. Excuse me. So does the length of the parachute strings increase or decrease the speed of the descent? Again, we might start off very similar to the size of the parachute is the length of the string. Each string from the 4 corners of your parachute, those 4 corners connected to the little Lego man in the middle, they're going to start off quite small, 5 centimeters maybe, 10, and then 15, and working through. Again, the constant variables stay the same. This time I've got the type of material is the same, the height of the release, the weight of the Lego figure, and the size of the material is the same. The only variable that I'm changing is the length of the string this time. How to make a parachute. The video link below shows you a really easy way to make a parachute. Obviously it doesn't show you all of the different changes that you would be making for your variables, but it does show you a basic way how to make one if you're struggling a little bit on that. Again, I can't click on the video, boys and girls, so you can click on that link either straight from the PowerPoint, or I will copy that link underneath the video on our YouTube channel for you to watch. I was trying to think of possible stumbling blocks that you might have for this investigation and some questions that you might have or be worried about. So I've tried to get into your mind a little bit here. How do I calculate the average? Hopefully I've shown you that by adding up the time of tests 1, 2 and 3 and then dividing it by 3. The number of tests will give you the average. What if I don't have a Lego man? It doesn't need to be a Lego man, boys and girls. You are going to have to be a little bit innovative and change that. It could be just a piece of Lego, it could be a rolled up ball of blue tack. As long as you will keep that constant for each test, it is absolutely fine. So it's just something small and weighted. What if I don't have all the materials? So a good one, if you don't have all the materials, I would just go for the string. So changing the length of the string, and then you don't have to worry about changing all the different materials. If you don't have string, it could be some wool, some thread. It might be difficult, but you could try. An old pair of laces. I know I've got a few in a drawer upstairs just sitting there. You're going to have to get creative and think out of the box a little bit for that. Where should I release the parachute? So I was trying to think where in your house would be a good place to release it. Obviously, I don't know what everybody's house looks like inside. You could release it from the top of your stairs if you've got a banister going off. You might have 2 walls, so that's not possible. You could, with adult supervision, release it from a window upstairs, okay, and then count the number of seconds down. If you've got a bunk bed, you could release it from there. Okay, whatever you do, make sure that you stay safe. And definitely if you are releasing anything from the window, if you've got a main road near, maybe not advisable, okay? And just make sure that you've asked your adult and somebody's there watching you, okay? Okay, so just to recap, you need to go back through the slides and decide which variable you are going to change, whether that be the type of material, the size, or the length of the string. Okay, and really look closely at how we're making this a fair test, because all of the other variables, constant variables, need to stay the same. Okay, you need to fill in your test results and then answer your inquiry questions. So did the type of material affect how long it took the parachute to land? Did the size of the material affect it, or did the length of the string affect it? Okay, so you can upload your test results and the answer to your inquiry question on Teams. Good luck, everybody. I'm looking forward to seeing these.